students, we will be learning about side distance, and basically I will be starting with stopping side distance. So before going to stopping side distance, we need to learn what is side distance. So let me write the definition and I will be explaining to you people. So when it comes to the side distance means the length of the road which is visible to the eyes of the driver. So the length, the actual distance which is visible to the eyes of the driver who is driving the road, that is known as your side distance. Now the side distance has got certain classifications, not classifications, but basically it is comprised of certain other type of side distances. So first one is your stopping side distance, which is also known as your non-passing side distance. Now second one is the overtaking side distance. Which is also known as safe passing side distance. Now the third one is intermediate side distance. Then fourth one is headlight side distance. The fifth one is side distance at intersections. And the last one is decision side distance. Today I will be elaborating further the stopping side distance. So as we had already known about the side distance, that is the length of the road which is visible to the eyes of the driver, that is known as the side distance. So the side distance is governed by certain factors. So first one is the features of the road ahead, next one is the height of the driver's eye above the road surface, third one is the height of the object above the road surface. So these are the three particular factors which are governing the side distance. So let me write the factors, then I will be elaborating the stopping side distance. So the factors are, first one is the features of the road ahead. Then second one is the height of the eye level above the road surface. Third one is the height of the object or the obstruction, if there is anything on the road, above the earth surface. So basically, the height of the eye level and the height of the object. Height of the eye level, whose eye level? The driver's eye level. So height of the eye level and height of the object, both of the things are being given, the norms are being given by the IRC, that is Indian Road Congress. So Indian Road Congress has told that the height of the eye level above the road surface, it should be 1.2 meter above the road surface. Similarly, the height of the object above the road surface, it should be 0.15 meter. The same norms are for the stopping side distance. So now the stopping side distance, it is the minimum side distance which is available on the road surface, that is above the carriageway. At any spot, at any instance, it should be sufficient, there should be a sufficient length for it, so that the driver, he stops the vehicle safely without any collision with the obstruction ahead. If there is any obstruction, he should be having that much distance ahead so that he can stop that particular vehicle. Now stopping side distance, it has got certain factors which are governing the stopping side distance. So stopping side distance, the factors are, first one is the total reaction time of the driver. The total reaction time of the driver. Second one is the speed of the vehicle. Third one is the efficiency of the brakes when applied. Fourth one is the frictional resistance between the tires and the road surface. And the last one, if there is any kind of gradient on the road surface, then the gradient is taken into play. So the gradient, if there is any gradient, the gradient is also the factor which is governing the stopping side distance. So the first one is total reaction time of the driver. Now total reaction time of the driver is the very necessitating factor which is governing stopping side distance. Total reaction time of the driver, it consists of two types of timings. One is your perception time, another one is your brake reaction time. So perception time is the time in which the driver is having that kind of mindset, that is, he is understanding about the particular situation, he is bringing that thing into his mind that I have to stop the vehicle, I have to apply the brakes. So that particular timing is known as perception time. Second one is the brake reaction time. When the driver or the one who is traveling the vehicle, that particular person, he is applying the brakes, that one is known as your brake reaction time. So both of the timings, they come under the total reaction time. Now second one is the speed of the vehicle. Speed of the vehicle, when perception time and our total our brake reaction time, both of the things they also take into account the speed of the vehicle. So basically, when the total reaction time is increasing, the stopping distance is also increasing. When speed of the vehicle is increasing, similarly the stopping side distance is also increasing. Now coming to the efficiency of brakes, when your brake efficiency is more than 100% or it's almost equal to 100%, then what happens now? The wheels of the vehicle, they get locked, as a result of which skidding kinds of condition can take place. So what is skidding and what is slipping? We have two conditions which are very harmful for the vehicle and the passengers who are traveling in the vehicle. So slipping is the one in which the longitudinal movement is less than the circumferential or the rotational movement, and the reverse one is the skidding. In skidding, what happens? The longitudinal movement is more than the rotational movement. Now when the wheels get locked, as a result of which the brakes can't be applied, so what happens? The vehicles tend to skid. So there should be the frictional forces which should be very necessitating, and they should dominate over the braking forces. As a result of which, what happens? The skidding forces, they get reduced, and frictional forces, they easily they become the safest condition for the vehicles to travel further in the road. Next one is the frictional resistance between the tires and the road surface. Now what is the frictional resistance? That is the speed resistance. Now speed resistance, there should be a particular norms. According to the norms, IRC has given about 0.35 to 0.40, which is given the frictional resistance, and it is a longitudinal friction. Since we know the skidding is the problem which is mainly occurring due to the locking of the wheels and all. So longitudinal movement should be less than the rotational movement, and for that particular thing there should be a safest condition, and that will help in the safety of the vehicles, and that thing is known as the frictional. In frictional resistance, we have the longitudinal coefficient of friction, that is from 0.35 to 0.4. Last one is a gradient, and in gradient we have rise or fall that of the road conditions, that is 1 in n, that is the number of vertical rise and falls with respect to the x units of horizontal units. So this much about today. In next class we will discuss the further ones. Thank you.